So we're going to just do a quick how to get something working with an Arduino. So people say Arduino to mean a lot of things. The way I see it is that it's a system of software both on the computer and also on a little microcontroller. So on the microcontroller you have a little bit of software which is called a bootloader. So that's a very small bit of software, but that allows the computer to easily talk and put new code onto the microcontroller. So that, when I say Arduino, I mean the Arduino, it's called the IDE, the Integrated Development Environment, and also the bootloader on the microcontroller here. There are thousands of different microcontrollers, and Jean-Marc was talking about the tool chain for putting data onto those. Arduino was designed for, it was originally started in Italy, and it was designed as an easy way for getting designers and artists to get sensors and information in and out of a little computer, a little controller. It was designed to be easy to use and quite cheap. Some of the terminology has carried on from the fact that it was designed from an artist's background. So when we look at a program, they're not called programs, they're called sketches. And you put your sketches in a sketchbook. So the terminology comes from that background. Nowadays, it's used for very rapid prototyping of things. The best thing about Arduino, in my opinion, is the huge user base and the knowledge base that there is.
Library.
It's just, libraries. So people, you don't have to keep on writing code to do everything. You can look at, someone else will probably have written something, and you can just download that and use it in your program, as long as you allow it to be open source and you acknowledge that they wrote it. That can mean that the software can be badly written or it can be very well written. So you have to trust the software, the libraries that you include. But normally they're very well written, and because so many people use it, because so many people use Arduino, there's a lot of people testing it. So, and if you want to make an improvement, you can generally make an improvement to the library that will then get repeated, and when the next person downloads it, there will be a better library. So there's so many people using it that the libraries are actually very good, quite quickly, for most things. So the Arduino itself, there are lots of different types. So this is one particular type, which is called the Uno. This is not actually bought from Arduino themselves. This is a Chinese manufacturer making the same thing, but it's open source, so it's okay that they can do that, because it's open source and anyone can make them, so long as they don't use the Arduino symbol and they don't call it an Arduino. So this is the XD Arduino Uno. So there are two main components to this, one of which is this is the microcontroller, and in the Uno, the microcontroller is an Atmel AT Mega 328. It has 32 kilobytes of memory, with 2 kilobytes of program memory, and I think 1 kilobyte of EEPROM. So the memory, you don't have to worry about that, but you use those for different things. The bootloader on this takes up about 1 kilobyte, so you already waste 1 kilobyte of your 32 kilobytes just for that little bit of program. The other component on here is another microcontroller, but all this is doing is allowing you to plug USB into here and then communicates through a serial connection to the microcontroller. So the program is uploaded actually as a serial connection of transmit and receive, and then that's how you put new code onto it. You send just down 2 lines. So this component here is built into an Uno, but what you can do is once you've got this program working and doing what you want, you can take that chip out and you can use that in your device without having to pay for all this. So that's what I do with this Datalogger. So that component there is exactly the same as that one, but just a different package. But I don't have any USB converter, and I use a plug-in. It's not this one. I don't know where it is. There we go. Okay, so you can use something like that, and I can plug in and I can reprogram it. But I can do that for all of them, so I'm saving a couple of dollars or a couple of pounds, a couple of euros. So that's the kind of hardware. So that's the hardware and the software on the little chip here. There is also an IDE, the Integrated Development Environment, which you can download for free. You can also donate some money to them, and you probably should if you're using it a lot. You can download, but it's for every type of platform. So it works on Windows, it works on Mac, it works on Linux. And I've already downloaded it and installed it. It's not huge, but so it doesn't matter which operating system you use. You can also look on here the different products that Arduino sell. So, like I said, this had 32 kilobytes of RAM. There are, if that's not enough, there are other versions. So there is the Mega, which has 256 kilobytes of RAM. So it's much bigger. And there's lots, not just from Arduino, there's lots of Arduino compatible products. So it depends what you want to do. This only has 13 digital inputs and outputs and 6 analog or digital inputs and outputs. So you might be limited by that. So the Arduino Mega has, I don't know, 32 inputs, I think, and 8 or 12 analog inputs. So there's a lot more bits. Also, if you want something that's much smaller, you can get ones which are like the Nano is just tiny, it's only this big. So it depends what you want. The Uno is probably the most standard one, the common one that you get everywhere. So what we can do here, I'm going to open up the Arduino IDE. And when it opens up, it starts with an empty, like I said, they're called sketches. So this is an empty sketch. And there's a couple of things to check. So we're going to plug in our board. So that's just a USB into there. And we should, when you install the software, it installs all the drivers as well for this. So it should just work. What we need to do is look at tools, just to make sure it's all going to be okay. We look at the board. So for the different types of Arduino, so the Nano that I was talking about, or the Mega, there's lots of different ones. You have to make sure you're clicked on, if you're using an Uno, to click on Uno. And then you also need to just look at the communication port. So this is a serial port, and you can see here that it's actually come up as Arduino Uno on COM6. So I'm going to connect to that one. And we should see down at the bottom here that it says Arduino Uno on COM6. That has to be correct or you won't get any, it won't work. The other good thing about the IDE is that there are lots of examples. So if we go to File and then Examples, we can see that there are the basics, and then there's digital examples, analog examples, communication examples, control examples. So one of the best ways of learning how to do code for the Arduino is to go through the examples and have a look at how they write things and what they do. And it's as easy. So the first thing we're going to do is we're going to use the blink, which will turn on and off an LED. And it's a good one to start with to make sure that everything is working okay. So I'll make it full size. And you open it up. On the Arduino Uno, there is always an LED connected to digital pin 13. That's just a standard. And it's good for just making sure things are working okay. There are two parts to your code. There is always the setup function, which I just have a look at the example, but it's a function. So it's void setup and then open close brackets, and then everything in the curly brackets will happen when the thing starts up, but it'll only happen once. And then you'll go to the loop, and everything in the loop, like it says, loops round, and it just keeps on going round the loop. So it will start up through the startup and then loop around the loop. Pretty obvious. So the reason we do that is a lot of electronic sensors and components and equipment needs to be initialized in some way. You need to say you are a sensor, you're a temperature sensor, you're reading in Celsius, this is your calibration coefficient. But once you've said that once, you don't have to keep on saying it. So and then to actually get that code onto here, it's as simple as just clicking upload. And if we wait a little bit, we should see some lights here flash, but probably not for very long. There we go. That was it. So that uploaded the code. Uploaded the code. And our code here is designed to write to pin 13 high, then it will delay for, this function here is delay in milliseconds, so it delays for 1,000 milliseconds, which is a second, and then it sets it low. So that should turn on and off at about 1 times per second. On for a second, off for a second, on for a second. It's not quite exactly 1 second because the time taken to write the pin to be high, to give you a high, that takes a little bit of time. So the delay might be very accurate, but because it takes some time to do the writing, you've got that added on. So it's not exactly 1 second. So you have to be quite careful with timing, but that's for the future really. But so there's a few things we can do here. We can change the time. So let's try changing the time. And now when we're finished, it should, let's say, turn on for half a second and off for 2 seconds. And then all we have to do is upload it. And so now it's half a second and then off for a long time. So it's as simple as that. You save your sketches, these are, as I said, they're called. You save them to a sketchbook, and there are some preferences to find out where that sketchbook is. That's a bit more detail. So let's try writing a digital output to one of the other pins. So I'm going to use this just an LED, and you have to know the long lead is positive, short lead is negative, and then there's also on the side that one of them is flat. So one side is flat and that is the negative side. And we also need a resistor to just reduce the current, and in this case I'm using a 1 kilo ohm resistor. And then I'm using this breadboard called.
So what happens if you don't put the resistor in? The LED blows up?
Yeah, there will be no current limiting, and the LED with 5 volts might be okay, but will blow up in time.
Is that the pull-up resistance, you call it?
It's not a pull-up resistance, no, it's a current limiting resistance. So, pull-up resistance is to stop a digital signal floating, which I'll show you in a second actually, because that's it's quite important because it can give you weird results. So I'm just going to connect the negative of the LED to, you see on here there are some power connections, so there's 3.3 volts, there's 5 volts, there's some ground. There is a power supply here, so you can apply, I think it's 7 volts or more, up to 12 volts, and that will power your Arduino with a nice regulated your microcontroller has regulated voltage. It runs at 5 volts. The microchip will actually run from about 2.7 volts to 5 volts. So I'm going to connect the ground there. And then which pin do you think we should use to control the green LED? We can use any of these, doesn't matter. Which one would you like to use?
Okay, the number 0.
Number 0, okay. So at the moment that's not been programmed to do anything. So what we're going to do is add to this code.
So we say pin
Pin
mode 0 output.
That's it. So pin mode tells us when we set up everything what that pin is going to do, and we're going to call it an output as well. And there's a little bit of syntax. You have to make sure every line is finished with a semicolon. And then we're going to do digital right, and then it's
0.
0, and we're going to go, let's go the opposite, so let's go low to start with, and then digital right, 0 high. So now if we do that, we should see, so we can see that it does the opposite. So that is on for 2 seconds, then off for half a second. 1 kilo ohm is probably a bit high resistance, that's why it's not very bright. There's another thing that we can do to make our code look a little bit nicer. We can actually initialize some values so that, so I'm going to create an integer, so an int, and I'm going to call it LED green. So this is the integer for my LED green, and that's going to be pin 0. So now every time I say the pin mode 0, rather than saying 0, I can say LED green, and that's the same as saying 0, but it does mean that we can change things quite easily without changing all of our code. So now I've changed it that every place where we've mentioned the pin that the LED is on, I've changed it to LED green, so that will be 0. The thing should do exactly the same. So it's doing the same as before, but if I wanted to say change to pin 6, rather than having to go through and go, oh, it was pin mode 6 there, digital right 6 there, digital right there, I can just go
int LED green.
Int LED green 6, upload, and now it does the same thing on a different pin. So look at the examples, there's loads of, you can go as far as you want into code. One thing that's quite interesting is to see that we can get data back from the serial, so that this unit will send out serial data, and that will be converted into the USB data, which we can look at on the Arduino. So I'm going to use the example in basics. Digital read. Let's just close that one down. So now I'm going to put a bit more of a delay in there. Let's put 100. So this one, it starts the serial port. There is a push button, so a connection on pin 2, and it's reading what the button is, and then it's writing to the computer what that button is. So if I upload that, I'll need a piece of wire to just... So what it means is that on pin 2, I have a... There we go. So you can see that that pin is at 0. And then if I apply a voltage, that goes to 1. So I'm just connecting that like you would connect to a switch to positive or something like that. And then if you take it away, you go to ground, it goes back to 0. Oop, goes to ground, 0, 1, 1. So that's a way of reading in data from the things and putting it into a computer. Yeah. And then the last thing that we'll just go through now is reading an analog data. So we have 6 analog inputs, and I'm just going to take the example, the very simple example. I'm not going to worry about that. So this is the basic example, and it's reading the value on A0, and it's just printing it onto the screen. I'm going to just give it a bit more of a maybe we can use 200, a little bit more of a delay because I don't like. So we're going to just going to get rid of all this because this isn't doing anything. I'm going to use variable resistor. I'm going to put 0 on one side, 5 on the other, and that means this will vary from 0 to 5 volts. Ooh, I might have just ruined it. Oh no, something went wrong there. Well, don't short out your thing when you're doing it. Don't film this bit. There we go, okay. Sometimes if you disconnect it, it's not very good. It doesn't like it. So I'm putting 5 volts on one side, 0 volts on the other, and then the output is going to the analog input 0. So if I then look at the serial monitor, we'll see a number there, which is a reading, and it will vary depending on where this is. So that's 123 down to 0. So there we're reading an analog value, and it's as easy as that to get analog data. The reason it's 1023 is that this has a 10-bit analog to digital converter. So 2 to the power of 10 is 1024. So
This is 0.
so that's, yeah, so 0 to 1023 is the same as 1 to
24
1024.
values.
So that's why we get a reading. So all our values in the Arduino, our analog values, will be in the range of 0 to 1023.
Okay.
You can convert them in program to whatever you want,
Yeah,
but the actual data you get in, and that also gives you the range, the sensitivity of it. So 0 is 0 and 1023 is 5 volts. So every little step is actually 4 millivolts if we use 5 volts as our reference voltage.
Yeah.
So there you go, that shows you how easy it is to get data in. And we can write a little statement to turn on and off an LED depending upon the value here. Actually, I think there was an example that does that. So don't do that to me. Okay, so this is quite an interesting one. So this code will control the output to an LED depending upon the sensor value, so the analog value. So we're reading in a value from 1023 to 0, so you can see on this side. That has been mapped to a different value, which is 0 to 255. And then if you look at the brightness of the LED, so as I change this, it gets brighter.
Yes.
That is actually
Dimmer.
PWM, so that's pulse width modulated. And that's what you're doing, you're controlling the pulse width with the thing. So it's as simple as that to really make we were saying yesterday that we could just make a voltage regulator. You measure the voltage, you control the MOSFET, control the load. There you go, it's nearly one of the example things.
Yeah,
You can just
it's
do it.
very easy.
So easy. Obviously there are other bits you need to think about, but yeah. So that's basic Arduino. The best way to learn is by looking at the examples and trying stuff out. Buying an Arduino for £20, 30 euros, whatever they are. There we go. So you can have a play if you want to try out anything.
Okay, thank you.
No worries.
Thanks, Matt.
Oh, thank God.